Hey guys, Mr. T here, just doing another video on the 2018 General Mathematics exam, doing the solutions for this. So once again, doing it live. Been sitting doing exams for a few hours now, so I'm getting a bit tired, but hopefully I can smash through this one, show you how it's done. So doing it live, no cheat sheet, hopefully I remember everything. And I'm typing everything in the calculator, no pre-prepared notes. Just a print out of the exam so that I can read the questions separately as well. Alright, so let's get started. Alright, Demetrios. Friggin' Demetrios. He needs 150 grand to set up a business, interest-only loan, so that's important to highlight, charging a flat rate of 4.3% per annum, doing it every half year. He wants to do it in 3 years. Calculate the half-yearly interest payment for the interest-only loan. So interest-only loans, SI, is equal to PRT, so 150 grand, times by the rate of the decimal, 0.043, times by the number of years, 150,000, times by 0.043, times by 3. So 19350 interest total. However, it's half yearly for 3 years, and we want to know what the half yearly interest payment is. So it's going to be 19350 divided by 3 years, there's 6 half years in 3 years. So 19350 divided by 6, $3,225 half yearly interest payments. Sinking fund earns 3.7% per annum, compounding monthly. Just had dinner, so I'm burping a lot. Sorry. N is going to be monthly, so 12 times by 3, which is 36. The interest rate is 3.7. Starting off with nothing in the sinking fund. We're trying to prove what the PMT is. The FV is meant to grow to 150,000. PY and CY are both 12 because it's monthly. So apps, finance, TVM, 36, 3.7, 0, solving for PMT, 150 grand, 12, alpha, enter, negative 3946.11 to 2 decimal points, therefore $3,946.11 per month, which is approximately equal to $39.40. Calculate the total cost of the interest-only loan and sinking fund option. So total is going to be the total interest only that you pay, which you worked out in A, which was $19,350, plus 36 payments of $39.46.11. Dog's barking. Plus 19350. Total is $161,409.96. Total cost of interest only loan and sinking fund. So don't forget your answer statements, people. First page down. As an alternative option, Demetrios could have borrowed 150 grand using a normal reducing balance principal interest loan with a rate of 3.9% per annum, compounded quarterly. What's the total cost of this? So to find the total cost, we need to know what the payments are. So N is going to be, it's 3 years, but he's paying it quarterly, so times by 4. It's a total of 12. Interest rate is 3.9. He's going to be getting 150 grand straight away. I'm trying to calculate the payments. I don't want to owe anything at the end. PY and CY are both 4 because it's compounding and being paid quarterly. TVM solver, 3 times 4, 3.9, 150 grand. Owe nothing. 4. Alpha sulfur PMT comes to negative 13306.28 to 2 decimal points. So total cost is going to be 12 payments of $13,306.28. $159,675.36. So I have to compare that to the previous question. I have to quickly work it out in the other. Oh, it's on my calculator from previously. 161409.96 minus 159,675.36. $675.36. $1734.60 cheaper than the interest only loan plus sinking fund option. Make sure that comes across as a 3. $1734.60. That question down. Moving on. Population of abalone exists off the coast of Tasmania. Random sample. Distribution was normal. It's got a mean of 110. Standard deviation of 20. Minimum legal length is 130 mils. State the proportion. So you're given a number, you're not given a percentage, so this is a normal CDF question. The minimum legal length. So what do I need to find with that? It's going to be, I'm interested in everything up to 130. Because everything below 130 is shorter than that. So a mean of 110, standard deviation of 20. Second, vase, normal CDF, negative. Second comma for E, 99, 130, 110, 20, paste, enter, 0.8413 to 4 decimal points. Therefore, 84.13% are expected to be shorter than 130 millimeters. Marine scientists believe that only the longest 60% are capable of reproduction. Show that the shortest capable of reproduction is 105. So you're given a percentage. So this is an inverse normal question. I have an older calculator, so the inverse normal only works with the tail to the left. So I need to convert top 60% It's equivalent place to same place as bottom 40%. Because I've got an old calculator, I can't change where the tail is. So 0.4, mean is 110. Standard deviation is 20. Oh, and just to show the people with the new calculators, I would be putting left here. Second, vase. Inverse normal, 0.4 for the area, 110. 20 is equal to 104.93 to 2 decimal points. Therefore, shortest capable of reproduction is 104.93 millimeters, which is approximately equal to 105 millimeters. Total population of black-lipped abalone in the reef is estimated to be 3,500. You're being given a number here, so you're probably going to work out how many abalone in a certain range. How many of these abalone could be expected to be long enough to reproduce, but shorter than the minimum legal length. So we've gotten these numbers in the previous parts of the question to answer this one. We're finding how many, but I need the proportion to start off with. So this is a normal CDF question. So minimum legal length is 130 and shortest reproducing is 104. So the lower boundary is 104.93, upper boundary is 130, mean is 110, standard deviation is 20. Second vase, normal CDF, 104.93, 130, 110, 20. Proportion is 0.4414 to 4 decimal places. I want the total I want the number of abalone, so it's going to be 0.4414, 44.14% of the estimated 3,500 abalone. $1,544.9. So therefore we can't have part abalone, so we're going to round down approximately 1,544 abalone. Long enough to reproduce, but shorter than min legal length. Alright, that's that page down. On the same reef is another species, Thompson's. The lengths are normally distributed. There's a mean of 140, standard deviation of 30. The population size is approximately the same. I don't know why you didn't give a number or whatever. The minimum legal length for possession of a Thompson's is 165 millimeters. If an abalone of legal length is collected from the reef, which species is it more likely to be? Well, what's the chance of abalone being smaller than legal length for this new species, normal CDF, negative E99, comma. I'm interested in what proportion of them are below the legal length of 165, 140, and 30. Second vase, normal CDF. Second comma for E. I need to do the negative sign. Second comma for E again. 99, 165, 140, and 30. is 0.7977 to 4 dp, therefore 79.77% are shorter than min legal length. So, is it more likely to be, which species is it more likely, if an abalone legal length is collected from the reef, which species is more likely to be? So, what we found from the previous, so I need to look in my calculator. Before, the proportion below minimum legal length was 84%, now it's 79.77. There's 79.77% shorter than the minimum legal length, so there's less that are illegal, so more likely to be Thompsons, abalone, as there is a smaller proportion of Thompsons. It's Thompsons with an apostrophe, Thompsons that are below minimum legal length, doesn't start with a T, than the black lip. Just a reminder, 79.77% versus 84.13%. The graph below shows the probability distribution of the lengths of abalone. Black lip's drawn already. I need to draw two on the same axis. So black lip height 0.4 divided by, I believe it was 100 and, it wasn't 110, it was what was the standard deviation? Standard deviation of 20. 0.4 divided by 20, 0.02 and of black lip, so that the peak there, didn't draw that peak in the right place, that should be 0.02. What's the height of the Thompsons? Height is equal to 0.4 over, now it's 30, 0.4 divided by 30, 0.013. So Thompson's is centered around 140. So I'm going to draw a line vertically up from there. 0.03, 0.02 divided by 0.013. It's about 1.5 times the size not 1.5 times the size, it's half as much, so it's not going to be, it's like 150%, sorry. The height of, because I just did 0.02 divided by 0.013, it's about 1.554 to 2 decimal places. So that's telling me that the Thompson's abalone height should be like 2/3 of the way up, because the black lip is 150% of it, so we need to mark off about yay high, that's a little high. There, about there, that's going to represent 0.013. And the standard deviation is 30, so 140, 150, 160, 170. So point of inflection is going to be 1 standard deviation away, halfway down. Another standard deviation away. Now we need to go 3 again, 1, 2, 3. And then another 1, 2, 3. So 3 standard deviations away at 230. 1, 2, 3. 1, 2, 3. So the graph finishes on about the same place. So concave section, then convex section, about like that. Alright, so that's that page done. Moving on. Oh, now we're at question. Question 3. Adam wants to install festive lights. He's identified tasks. Networks drawn for you. List all the tasks that must be completed before task K can begin. So K is here. So we have a dummy link. A and B must be completed. C, D, and F required too. So tasks A, B, C, D, F must be completed before task K can begin. Use the network diagram, complete a forward and backward scan in blue and red. Sorry. That's going to be on YouTube. 7, 2. Only one way to this. 7, 8. One way to this. 12. 7 plus 4 is 11, but 12 plus 0 is the larger number. 12. 7, 8, 9, 10, 11. Could be 11 or 8, 9, 10, 11, 12, 13. 12 plus 2, 14. It could be 12 plus 4, 16, or 14 plus 16 from both ways. And then 13 plus 2, 15, or 16 plus 3, 9, 19. Going back the other way, 19. 19 minus 3 is 16. 16 minus 2 is 14. 14 minus 2 is 12. 16 minus 4 is 12. It looks like we've got 2 critical parts here, I think. 19 take 2, 17. 17 take 4 is 13, but 12 take 4 is 8. 17 take 5, 12, 8 take 5 is 3, or 12 take 6 is 6, so 3, 6 in a box here. 12 take 5 is 7, 7 take 7 is 0, 3 take 2 is 1. 12 take 0 is 12. So this is tricky here, because you've got 2 possible critical parts up through there, or through the dummy link through here, and there's not going to be a box number along here, because 12 take 0 is 12, 14 take 2 is also 12. So just take care here, follow all the rules, you'll be right. List all the tasks that are on the critical paths. So here's a little hint that you've got a more complex situation. A, B, I should highlight it first. B, A, B, J, K, L, M. Why are these tasks considered critical? They have no slack time. EST is equal to LST. So cannot be delayed without delaying the overall project. That's that page done. Next, if Adam wants to finish the installation of the festive lights display on the, what's that, 30th? I need to read the printed. 30th of November, what's the latest date on which you can start the installation? Well, the whole thing took 19, and he wants to finish on the 30th. So the 30th minus the 19 days it takes. 30 take 19 is 11, therefore start on 11th of November at latest. State one task that could be delayed by 2 days and not result in an increase in the minimum completion time. So there's a few tasks with a lot of slack time. So any task with slack time of 2 days plus could be delayed by 2 days. Therefore, task H, H we'll do alphabetical order. Tasks E, G, H, and N could all be delayed by 2 days with no effect. Better be certain on completion time overall. Adam's friend Trang has time to help with only one of the tasks. She's offered to help with task L, task M, or task N. Trang's help will reduce the time for any of these tasks by 1 day. For each task L, M, and N, state whether or not Adam should choose to have Trang help. Justify each answer. So I need to quickly do the scan again on my piece of paper so I don't have to go back and forth between the pages. So there's going to be a little delay here while I do that. 0, 7, 12, 14, 16, 19, 2, 7, 12, 8, 13, 19. Let's do my backward scan. 19, 16, 17, 12, 14, 12, 8, 7. Alright, so now I can answer this question properly without having to flip pages. Task L. Should not help with L as it is on the critical path, but there is another critical path that L isn't on. So the other critical path would apply if L was shortened, therefore no overall effect on project. Task M, what's going to happen in task M? Task M is definitely on the critical path. It's on both options, so should not help. Should help with M, as it is part of both critical paths. So affecting it will affect the overall project. Therefore, definitely have an effect on project. Task N. Whereabouts is task N? Task N has slack time, so should not help with N, as it has 17, take 13, 4 days slack time, therefore not on crit path, therefore would have no effect on the project, making it faster. That's that page done. Moving on. Alright, we're going to have for a stats question, I believe. Eco homes construct houses. Floor area is found to correlate with price. Interpret the meaning of 457.91 in this equation in context of the question. Well, normally the bigger the house, the higher the price. The slope is positive, so that's suggesting that the price increases by $457.91 for every 1 square meter of floor area. State the value of Pearson's correlation coefficient and its meaning. We haven't been given it, so we need to put the data stat, edit, list 2 clear, list 1 clear. Floor area is the independent variable, so put it into column 1, 120, 126, 226, 248, 264, 150, 165, 264, 203, 200, 205, 000, 173, 300, 176, 200, 228, 100, 234, 000, 235, 200, 185, 400, 193, 100, 238, 700. We need to find Pearson's correlation coefficient, so stat calc. You can give me a linear regression equation, so linreg, it, stat calc linreg. So R is equal to 0.9931 to 4 decimal points. This means that the correlation is in a positive direction and is very strong, and you assume it's linear because you were told it was a linear regression. Valaris. What's up with the names? Valaris wants to have a house built and he has $210,000 to spend. Use the linear regression model to determine the floor area of the largest eco homes house that Valaris could expect to purchase for 210 grand. So you know the price is 210,000 is equal to 457.91 times by the area, which we don't know, plus 119072. I need to subtract 119072 from both sides. So 210,000 minus 119072. So it leaves you with 90928 on this side and 457.91 times by A on that side. Divide both sides by 457.91, giving you A is equal to 198.57 to 2 decimal points, therefore approx 198.57 square meters for 210 grand. That's that question down. Next page. Valaris now decides that he needs a house with a floor area of 135 square meters. He contracts EcoHomes to design and build it for him. How much can he expect to pay? So this time you don't know what the price is, but you know the area. So 457.91 times by the area of 135 square meters at 119,072. 457.91 times 135. Add 119,072 to that. That gives you $188.89.85. Therefore, expect to cost $180,889.85. They're adding a new house design, area of 332, cost 322,040. How will adding the data for the new house design to the existing affect the following? So it's on the extreme side, and it's higher than everything that we've got, so it's going to pull the slope up vertically. The slope will increase. At the end of the day, if you're not sure about this, just add the actual data. So go stat, edit, add the data to your stat edit, 332, 322,040. So you're not doing guesswork, so do stat. Calc again with the new set of data where you've added this new one. So either you see the slope has gone up to, the equation changes to 602.52a plus 94031.55. I was trying to do guesswork before, but looking at these, you'll need to do a stat calc linear regression with the new data. So the slope will increase. We can see that there. The y-intercept decreased to 94031.55, which we see there. The value of Pearson's correlation coefficient is now lower, because it used to be 0.99 something. What was it? 0.9931. Now it is 0.9566. Alright, so that's that question done. Moving on. Question 5. Laura's 23 years old, setting up for a super account. Laura's employer contributes 1,235 to a super each quarter. And a super fund pays 6.8% interest per annum, compounded annually. So highlight 1,235, 6.8% compounding quarterly. Turns 45, have approximately 250 grand. So 45 minus 23. We need to work out how long this account is going for. 22 years. So n is going to be 22 times by 4 for quarterly, which is 88. The interest rate is 6.8. Doesn't say she's starting off with anything, so PV is nothing. PMT is equal to negative 1235. We're trying to work out what it grows to. PY and CY are both quarterly, so 4. Apps Finance TVM 88, 6.8. Nothing, negative 1235. 4 and 4 comes to 247,582.85 to 2 decimal points. Therefore, she has $247,582.85 at 45, which is approximately equal to 250 grand, like it said in the question. Calculate the interest that will have been earned in super account when Laura turns 45. Remember, this is an investment, so interest is going to be the final value, 247,582.85, minus the payments that were made into it. So she doesn't start off with anything, so it's 0, plus 88 payments of $1,235. Do bed maths probably. 88 times 1235. Take that away from 247,582.85 minus second answer. 138,902.85 interest earned. If Laura retires when her super account balance reaches 1.5 million, how old would she be when she retires? So how old? It's the same as how long. It's the same as finding n. So finding n, interest rate is 6.8. PV started off with nothing. PMT is negative 1235. She wants to finish at 1.5 million. Still doing it quarterly. Apps, Finance, TVM. Solve for n. 182.41 to 2 decimal places. Wants to say how old, so that's going to be in years. 182.41 divided by 4 quarters in a year. 45.60 years, 2 decimal points. Therefore, 23, which she is now, plus 45.60 is equal to 68.60 years old. State one assumption apart from interest rate remaining constant that's being made when doing the calculation. Explain how it affects. You assume that Laura's pay remains the same. Making her contributions the same. At 1, 2, 3, 5. If her pay increased, she would reach 1.5 million at a younger age. If it decreased, she would reach 1.5 million at an older age. You could possibly mention lump sum. part of this same assumption is that she keeps her job, she doesn't become unemployed, that sort of thing. There's a few answers that you could give for that. So that's that page done. Page 11, when Laura retires, she decides to invest her $1.5 million in an annuity. She's identified two options. Calculate the effective rate for option A. Option A has that, compounded weekly. Option B is that, compounded monthly. So both are compounding, so we can use the EFF function. EFF, bracket, nominal rate, 3.75, comma, number of compounding periods per year, which is 52. So apps, finance, scroll down to C, which is EFF, 3.75, comma, 52. Gives you 3.81, not 81, 82%, 2 decimal points. Effective rate. I reckon I've lost 5 minutes to burp in this. EFF for option B, 3.76 is the nominal rate, but it's compounding monthly, so 12. Apps, finance, scroll down to C, EFF, 3.76, comma, 12, 3.83% rounded to 2 decimal points effective rate. Just to be more pedantic, it's per annum. Might lose marks there. State one reason why Laura might choose to invest in option A. So this is an investment. You want the highest rate possible. So there's really no good reason to want a lower rate unless you're getting some form of freebies or you're really happy with their customer service or something like that. So the only reasons you'd probably have is might have or might be an existing customer. Of the bank with option A, get perks to stay with them, or might prefer the weekly. Calculations for budgeting, it's pretty weak, that one. Really, it's probably going to be the first one. State one reason why Laura might choose to invest in option B. It is a better effective rate. So a better return. She's going to get more money. Not better return. So she's just going to get more money with it because it's a higher rate. That's it. Laura decides not to invest in option A or B. She invests in option C. 3.78% interest, compounding fortnightly. She wants her annuity to last 25 years and she wants to finish with 100 grand at the end. Trying to work out how much can she be paid fortnightly. This is one of the trickier TVM solvers we've had to do and is going to be. She wants to last 25 years. Going fortnightly, so 25 times 26. Might as well open the TVM solver now. Apps, TVM solver, 25 times 26, 650. Interest rate is equal to 3.78. PV, well, she invests the 1.5 million option C, so she puts 1.5 million into the account, the annuity. We're trying to solve for the payments. She wants to have 100 grand to take out at the end. PY and CY. It's compounded fortnightly and fortnightly payments are both 26. 3.78. Negative 1.5 million. Trying to work out the payments. She wants 100,000 at the end. 26 and 26. Solve for PMT. So she will get she's going to get $3,476.33 to 2 decimal points. Therefore, paid $3,476.33 per fortnight in retirement. And that's that page done. Moving on. Alright, first matrix question. Shopping centre has 4 children's rides. Shops A, B, C, D. Rotates the rides. Weekly profits. Which children's ride appears to be the most popular? Well, we're just wanting the one that has the highest profits. Tractor, as it has the highest profits in every location. Shop A, it's 50. Shop B, it's 45. Shop C, it's 50 again. Shop D, it's 58. Everyone likes the tractor. Center management wants to assign the rides to make the maximum total profit. So I haven't done any other maximizations today in the last few hours. Complete the array below for the first step of the Hungarian algorithm used to find the maximum. So they've done part of the maximization step. So you're subtracting all of the numbers from 58. So just check that they actually did this properly. 58 minus 30 is 28. Okay, you're going to have to trust it. You're not going to have time in the test to fix it for them. You just have to trust that it works. So I'm going to go 58 minus 50 is 8. 58 minus 58 is 0. 58 minus 30 is going to be 28. 58 minus 35 is going to be 23. That's that page done. So luckily for you, they did the maximization step for you already. Mostly, you just had to do part of it. From the reduced array below, so they're doing part of this for you again. State the optimal assignments of rides to shops to make the maximum total profit per week. So they're just getting you to skip over and cover the zeros. So it's the most I can hit. I can hit 3. I can hit 3 again. I can hit 2 and I can hit 2. So I used 4 lines and there's 4 rows. So I can select my pattern of zeros. Is 0 alone in its row, alone in its column? No. Alone in its row, alone in its column? No. Alone in its row, alone in its column? No. Alone in its row, alone in its column? Yes. Alone in its row, column? No. Alone in its row, column? Yes. So now we've got a situation here. So you're going to have to look back. I'm going to look back on my printed test because it looks like one of these situations where you're going to have multiple optimal solutions because we can't actually choose out of here and here. You've got 2 rows choosing out of exactly the same columns. This row is left, this row is left, and you're choosing out of these 2 possible columns each. So car, I need to remember what the rides were. Car, ship, tractor, horse, arrows, could be shop A. Ship would be shop C. Tractor would be shop D. And then because car did A, horse would be B. Or because of the multiple optimal solutions, car, ship, tractor, horse. The car could do B. The ship would still do C. Tractor would still do D. But the horse could do A as the other option. State the maximum total profit that can be made per week. So you'll see for this one, car doing A is 30, ship doing C is 33, tractor doing D is 58, and horse doing B is 40. 30 plus 33 plus 58 plus 40, 161 for that first option. It's always good to check that your totals add up. Otherwise you've done something wrong and you haven't actually found a multiple optimal solutions situation. So car doing B is going to be 38 plus ship doing C is still 33, tractor doing D 58, horse doing A 32, 38 plus 33 plus 58 plus 32 is also 161. So we have chosen a multiple optimal solutions question. Therefore, max total profit is equal to $161 per week in the multiple possible solutions. Next page. The tractor ride has broken down. Oh no. And will not be replaced, hence the arrow becomes, so I can see straight away. Oop. 3 rows, 4 columns, it's not square anymore. Use the Hungarian algorithm. Really, I had lost 5 minutes just burping. Use the Hungarian algorithm to determine which shop will no longer have a ride placed outside it if you want to maximize. So we need to invert. So the highest number is 40. Maxing step. 40 take 30 is 10. 40 take 38 is 2. 40 take 30 is 10. 40 take 32 is 8. 40 take 20 is 20. 40 take 38 is 2. 40 take 33 is 7. 40 take 24 is 16. 40 take 32 is 8. 40 take 40 is 0. 40 take 30 is 10. 40 take 35 is 5. We need to square it now. Maxing step square. 10, 2, 10, 8, 20, 2, 7, 16, 8, 0, 10, 5, 0, 0, 0, 0. Smallest number in this row is 2, so take 2. Smallest again is take 2. Smallest is 0, take 0. Smallest is 0, take 0. It's the worst line ever drawn. 10 take 2, 8, 0, 8, 6, 18, 0, 5, 14, 8, 0, 10, 5, 0, 0, 0, 0. Smallest, 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 smallest. You're going to be minusing 0 from all the columns, so nothing's going to change, so I can jump straight away to the covering with lines. Largest number of zeros I can hit is 4. Next is another 4. That took 2 lines. That's not good enough. So the smallest uncovered number is 5. Eight take 5 is 3. Nothing. 3, 1. 13, nothing, 0, 9. 8 take 5 is 3, nothing, 5, 0. Nothing, add, nothing, nothing. Hitting my zeros again. I'm going to hit 3. 1, 2, 3. I'll hit another 3. 1, 2, 3. I can hit 2. 1, 2. And I can hit another 2. 1, 2. So I can pick my zeros. Align in its row. Align in its column. It's align its row. Align its row. Align its column. No. Align its row. Align its column. No. Align in its row. Align its column. No. Row, column. No. Row, no, column, yes. So we have a process of elimination situation here. This row can't do here because that's already taken. It can do this column. And the other row cannot do that column, so he's going to be the only one that can do that column. And so the last one that gets chosen is this one that's left over. So now you've got car, ship, horse, and the dummy link, which was nothing. So car goes to shop B. Ship goes to shop C. Horse goes to shop D. And nothing is placed in front of shop A. Therefore, shop A no longer has a ride outside. What's the maximum total profit that can now be made per week from the 3 remaining rides? Shop B car was 38. Shop C ship was 33. Shop D horse was 35. And you're not going to get profit from no ride out the shop A. So 38 plus 33 plus 35. 106. So $106 max profit per week. That's that page done. Question 7, Nirmala. Got more international names. He's planning to renovate a shop. Precedence table below. Use the info on the precedence table to complete the network diagram below. Indicate any dummy links with a dotted line. So you're told that there's dummy links. Here I can see shared prerequisites, but not exactly the same. So the dummy link is going to go from the shared prerequisite to the task with another prerequisite. So it's going to go from B to D. So A requires nothing, B requires nothing, C requires nothing. So that's why they come out of the start. D requires both A and B, but the dummy link is going to go from B to D. So D is going to come out of A, and the dummy link is going to go from the end of B to the start of D. E comes out of B. F comes out of C. G comes out of D. H comes out of E and F. E and F aren't currently connected right now, so I'll connect them up. So the H can come out. I comes out of G, H and J. That's weird because I haven't drawn a J yet. Let's have a look at J. J requires C. And then K requires G, H, and J. I and K are both going to go... I and K are both going to come out of G, H, and J. J requires C. So J is going to go here because K requires it. But K requires G, H, and J. They're not connected right now. So G, H, and J both go into K. And I requires G, H, and J as well. And then I is not a prerequisite. K is not a prerequisite. So I goes to the end. Namala's goal is to complete the renovation in 14 days. State whether it's possible. Justify your answer. Okay, we need to add these numbers. 3, B3, C4, D2, E5, F4, G4, H3, I5, J2, K4. So this question is saying you do not need to do a forward and backward scan. You can if you want, but what it's really asking you to do is just look at the different paths and see if the longest path adds up to 14, if it's possible. So 3, 4, 5, 9, 9 plus 5, 9 plus 5 is 14, 3, 8, 11, 13, 14, 15, 4, 8. So the longest path is already 15. Going through the middle, 3, 5, 8, 8, 9, 10, 11, 12, 13, 14, 15. The longest path's going to be 15. It's not possible without a forward and backward scan. Well, wait, I didn't even know if that's the longest path. I might as well check through. 4, 8, 11, 15 again. 4, 5, 6, 7, 8, 9, 10. 3, 8, 9, 10, 11. No, 16. 16 through there. The longest path is not going to be 14. So the shortest completion time is not ever going to be 14. No. Longest path through equals critical path equals shortest completion time is at least, I haven't even really checked all the parts. I just found one that was over 14. It's at least 15 days. I think I found a 16 one in there, so therefore cannot complete in 14 days. That's that question down. Question 8. Really, that's the only network question. There might be one at the end. A couple has borrowed 320 grand from a bank to buy. Term is 30 years. Interest rate is 4.5, compounding weekly. And the weekly repayment and is 30 times 52. It's going to be a big number. Apps Finance TVM Solver 30 times 52. 52. 1560, interest rate is 4.5 PV. The loan was 320 grand. PMT is what we're solving for. Want to owe nothing at the end of the loan. Payments and compounding periods are both weekly, so 52. So that comes to negative 373.91 to 2 decimal points. Therefore, $373.91 weekly repayment. Show that the outstanding debt after 5 years will be a certain number. So I'm going to change N to 5 years times 52. It's 260. Solve for FV. I'm just going to change, in payments. I'm going to make negative 373.91 specifically. That's what I'm going to use for the remaining calculations. So FV is negative 291,734.90. 2 decimal points, therefore approx 291,700 debt after 5 years. After the first 5 years, the couple inherits 10 grand. They deposit the money in offset account, attached to the loan account. Show that it will take 12-20 weeks for the couple to pay off the outstanding debt if they keep the offset in. So, solving for N, show how long. The interest rate is still 4.5. PV is the issue. So they still owe 291,734.90, but they're offsetting it by 10 grand. So it's going to be 281,734.90. The payments remain the same, negative 373.91. I want to pay it off down to nothing. PY and CY are both 52. 281,734.9. So N comes to 1220.45 to 2 decimal points. Therefore, we'll take 1220.45 weeks, which is approximately equal to 1220 weeks to pay off the remainder. Find the approximate amount of interest that the couple save by using the offset account. I don't like doing approximate, I like finding the real thing. So interest default. If they paid off the loan normally, the interest would be 1560 times by 373.91 minus the loan, which was 320 grand. 1560 times 373.91 minus 320,000. 263,299.60 interest if they just paid off the loan normally. Interest for the first 5 years, paying it off normally, 260 payments of $373.91, but you didn't pay off the whole loan now. You went from 320 grand down to $291,734.90. So the interest in the first 5 years, 260 times 373.91 minus 320,000 minus 291,734.9, $68,951.50. And then the interest after the offset is going to be 1,220.45 payments of $373.91 minus the remaining debt, $281,734.90 equals 1,220.45 times 373.91 minus 281,734.90. That's 174,603.56. So the interest total 68951.5 plus 174,603.56. That's going to be 243,555 $6 with the offset. I saved. The interest saved is going to be the default minus the offset interest combined. 263,299.6 minus the answer. It's going to be 19744.54 interest saved. That's a tricky one. But we got there. Next, the couple, they've got the playback controls on my iPad is blocking the thing, so I need to read my printout. The couple have used their inheritance to invest in a term deposit or pay a lump sum. They could have. State one advantage using an offset account. The offset money can be withdrawn at any time in case of emergencies. You always got access to it. Calculate the couple's outstanding debt after they had the offset account for 6 years. So N, 6 years, 52 payments. Six times 52. Interest rate is the same, 4.5 PV. I've still got in my calculator, $281,734.90. PMT is negative 373.91. I want to work out the outstanding debt, so FV. PY and CY are both weekly, so 52. Alpha solve. FV comes to negative 235,158. 158's the worst 8 ever drawn. And go all the way back. 158.19 to 2 decimal points. Therefore, outstanding debt of $235,158.19 after 6 years. The couple decides to close the offset account, spend the money on the holiday, calculate the couple's new outstanding debt. Well, 235,158.19 was with the offset. The offset was 10 grand, so they're going to owe 10 grand more. So it's going to be $245,158.19 debt. Calculate how long it will now take the couple to pay off the outstanding debt. So how long is n? Solve for n. I is going to be 4.5. PV is now going to be $245,158.19. Payments remain the same, negative 373.91. They're paying it off, so FV0, PY and CY are both 52. $245,158.19 for PV. Now for solve, 968.70 to 2 decimal points. Therefore 968.68 weeks, or 968.68 is 0.70 weeks, or divided by 52, or 18.63 to 2 decimal places, years to pay off the debt. So that's that page done. It's dragging on a bit, this one. Question 9. Diamonds. Weights and the value, so the heavier the more expensive. Determine the linear regression equation for the data in the form. So we have to do a lin reg, so we need to put the data into stat, edit, clear list 2, clear list 1. The weight is the variable that determines the price, so 0.19, 0.2, 0.21, 0.3, 0.31, 0.52, 0.53, 0.71, 0.75, 1.01, 677, 616, 643, 911, 1149, 2443, 2745, 4312, 5158, 206. So put the data in, stat calc, for lin reg, in the form y. So it's not asking you to use the variables, it's asking you to write it in that form. Y is equal to 11125.53 x plus, well, it's not going to be plus, it's going to be minus, because b in the calculator is minus 2276.38, and I rounded all of those variables to 2 decimal points. Use the equation to predict the value of a diamond with a weight of 0.21, so y when it's 0.21, 11125.53 times by 0.21 minus 2276.38. Do bed mass, 11125.53 times that by 0.21 minus 2276.38. Value of $59.98 to 2 decimal points. Value predicted for a diamond of 0.21 carats. Discuss the reliability of the linear regression model for predicting this data. Give at least 2 reasons. Well, what we've got is, go back to stat, calc, lin reg. We've got multiple ways to argue this. R is equal to 0.94, so seems to be strong. Relationship. And it is an interpolation. So should be reliable. Should be reliable, but what do you notice is we predicted 0.21. We have a 0.21 here, and the value is nowhere near what we were expecting. But so it's a bit weird here. It should fit the model, but it's not. So, but the predicted value does not match existing data for a 0.21 carat diamond. So may not be reliable. That's all I've got right now. That first one's a bit weak. So this is making up your 2 marks, I'm guessing. Let's see how we go for the next page. To finish off answering this question, residual plot shows a clear curved pattern. So linear relationship not appropriate for the data. So that's a weird one. This question needed you to go on and try to answer it to be able to do a better answer for part C. The residual plot for the data is shown on the graph below. One of the points is missing from the residual plot. Take the coordinates of the missing point in the space below. We don't have the highest one. We don't have the 1.01 to well, we need the residual, so we need to run a lin-reg and input the residuals. So I've done a lin-reg. I'll just check again. Calc lin-reg with the data. So it's done a linear regression. So now I go stat edit, go to list 3, press second stat for list, and then go to 7 resid, fill it up with residuals. So now I find that the residuals on my calculator, 1.01, has a residual of 2245.6. Set the coordinates, plot the missing point in the residual plot above. So you can see there's nothing, there's no point at 1.01. So 2245, 2500 is going to be there. So it's going to be around here. A bit lower actually. 250 is going to be a quarter, so it's going to be slightly lower. So that one's going to be 1.01, 2245.6. Now the other thing to mention here is now that we can see this residual plot, you can see a bit of a curved shape happening there, so that gives us a bit of a strong argument. So we've dealt with this particular question. I plotted, right, probably last page. It's decided, I can't read it again, it's blocked by my playback buttons. It's decided that an exponential equation is more suitable for the data Find the exponential regression model for the data in the form y, so y equals. So I haven't run a exponential regression yet. My data is in already. I just need to scroll down to stat calc, 0 expreg. So that tells me it's y is equal to 335.86 times by 36.86 to the power of x. Using the exponential model, calculate the predicted weight of a diamond valued at 7,500. So you're not given the weight, you're trying to find the weight, you're given the value. So you're trying to solve this. 7,500 is equal to 335.86 times by 36.86 to the power of x, and x is the weight. So you go to the graphing function of your calculator. Y1 is going to be 7,500. Y2 is going to be 335.86 times by 36.86 to the power of x. Clear the old graphs. 7,500. 335.86 times by 36.86 to the power of x. I'm going to set the zoom to zoom standard. So the calculator draws the default graph. Now I'm going to try a zoom fit. Hopefully it finds where they cross over by itself. So I see a blue line going across. Let's see, second trace, intersect, is it on the screen? It was able to find, so intersection at 0.86 and 7,500. That was rounded to 2 decimal points. Therefore predicted weight of 0.86 carats. Comment on the reliability of prediction made in part F1 and use mathematical reasoning to justify your answer. So always go back to the stat calc to get your R and R squared. R is equal to 0.9940 to 4 decimal points, therefore very close to 1, therefore very strong fit to exponential versus the it was 0.9425 for linear. What else was there? That's also reliable because the 0.86 carats fits the existing data for price of diamonds. So it's more matching than what we've seen before. Also reliable as this is an interpolation with R and R squared close to 1. There's a few reasons there for your 2 marks. Is that the last page? Yes, it is. Really tired now. Hopefully that helps you out. That's like 3 exams all in one go. Hopefully that helps you out. with their solutions, and I'll see you in the next video.